Welcome pre-cal students to the homework help video, page 117, 53 to 65 odd and 75 through 85 odd. Let's go ahead and get started and see how we do on these problems. Problem numbers 53 through 59 determine whether the lines are parallel, perpendicular, or neither. Wow, they really took it easy on you the first two, didn't they? Notice here that y is already all by itself. So you know the slope for this line is 26 over 3. And y is already all by itself here. So you know the slope for this line is negative 3 over 26. So these two lines would be perpendicular because one slope is positive and one slope is negative. So their signs are different. And notice the two fractions are inverses of each other. So these two lines right here, if you were to graph them, you would see they are perpendicular lines. All right, number 55. Boy, same thing. They're really taking it easy on you guys. Y is all by itself here, and y is all by itself here. So the slope for the first linear equation is 2/5. I'm just going to circle it. And the slope for the other linear equation is negative 2/5. Well, we know they're not parallel because parallel lines have to have identical slopes. That means their signs have to be the same, the numbers have to be the same, everything. So they're definitely not parallel. And we know they're not perpendicular because the signs are different, and that's good. But are these two fractions inverses of each other? No, they're not. And so these lines, if you were to graph them, you would see they are neither parallel nor are they perpendicular. All right, continue on to 57. Okay, finally some work. Let's take our first equation here. X plus 2y equals 5. And let's get y by itself. First of all, we'll bring the x over and we'll make it a negative x. Let's not forget there's a 1 in front of the x, so now we divide everything by 2. And we will end up with this equation right here. So the slope is negative 1/2. Now let's go on to the other linear equation, which would be 2x plus 4y equals 8. Let's bring the 2x over and make it negative. So now I'm left with 4y equals negative 2x plus 8. And now divide everything by 4. Well, negative 2 divided by 4 is negative 1/2. 8 divided by 4 is 2. And your slope, since y is all by itself, you know your slope is right here. Well, look, the two slopes are identical. Negative 1/2, negative 1/2. So if you were to graph these two lines, you would see they are parallel lines. All right, let's take a look at number 59. Now, in the first equation right here, y is already by itself, so we know the slope is 4. All right, now let's take the second equation and let's get y isolated so that we can see what the slope is. Okay, well, let's divide everything by 4. So 4y divided by 4 is y. 8 divided by 4 is 2. Don't forget there's a 1 right here in front of the x. Okay, so negative 1 divided by 4 is negative 1/4. So let's take a look at what we have here. The slope for this line is 4. The slope for this line over here is negative 1/4. So first of all, I notice they're not identical slopes, so there's no way the two lines are parallel. However, one slope is positive and one slope is negative. And notice how 4 is the same thing as 4 over 1. And if you flip 4 over 1, you get 1/4. Or if you flip 1/4, you get 4 over 1. So these two slopes have opposite signs, and they are also inverses of each other. So if you were to graph these two lines, you would see they are perpendicular. Okay. All right, let me get a drink here. Let's continue on to 61. Okay, they want us to find a line that is parallel and a line that is perpendicular to this given line right here. So we're going to call it, we'll put the symbol for parallel and then we'll put the symbol for perpendicular. Okay, first of all, we notice that the slope for this line right here is 2/7. So if the slope for this equation right here is 2/7 and I'm trying to find the slope of a line parallel to this line, then I know right away my slope over here must also be 2/7. I know the ordered pair that's passing through is 3/5. So I know what m is. All that I have to find now is my b, and I can write the linear equation. Well, we have a formula for that, and the formula is y equals mx plus b. So where the y is, I will substitute a 5. Where the m is, I will substitute 2/7. Where the x is, I will substitute 3. And then simplify this side over here. So 5 equals 6/7 plus b. 2/7 times 3, and then bring the 6/7 over and make it negative, and you will get 4 1/7 equals b, or 29/7 if you prefer. So 4 1/7 is your b. So the linear equation would be y equals, then put your slope in with an x, and then put your y-intercept in at the end. And there we go. We wrote a linear equation that is parallel to this equation right here and passes through this point right here. All right, let's try one now that's perpendicular. Well, let's remember, we already know the slope of this equation is 2/7. So if the slope of this linear equation is 2/7, then the slope of a perpendicular line to that line would have to be, well, we're going to change the sign. This is positive 2/7, so we'll use negative 2/7. And then you flip 2/7 and you get 7/2. And we know the line also passes through 3/5. So we are so ready to use our formula, y equals mx plus b. So where the y is, I will substitute a 5. Where the slope is, the m, I will substitute negative 7/2. And where the x is, I will substitute 3. All right, let's go ahead and simplify the right side. Negative 7/2 times 3 would be negative 21/2 plus b. And then if you bring the negative 21 plus 2 over and make it positive, you're going to get, you can use a graphing calculator to help you. 5 plus 21/2 is going to give you 15.5. Or if you want to put 31/2, that's fine. Either way is fine. So I know what my m is, I know what my b is, so I'm ready to write my linear equation. Y equals negative 7/2 plus 15.5. Okay? So there we go. There's my linear equation. And this linear equation right here is perpendicular to this one right here. All right, number 63. Well, notice y is all by itself, and notice my slope is negative 0.3. Now, my advice to you is to go ahead and make that negative 3/10. Because it's really going to be hard to take 0.3 and try to flip it. So I'm going to make 0.3 3/10, negative 3/10. So now I know the slope of the given line is negative 3/10. Now all that I have to do is find a line parallel to this line and perpendicular. So parallel. If I want to find a line parallel to this line, I know my slopes are identical, so I know my slope would stay negative 3/10. Now I'm going to use this ordered pair right here to find b. So y equals mx plus b. And I'm going to very quickly copy this. There we go. And now where the y is, I will substitute 0. Where the slope is, I will substitute negative 3/10. Where the x is, I will substitute negative 7. And now let's continue on. 0 equals, well, negative 3/10 times 7 would be positive 21/10. And then bring that over and make it negative, and you would get negative 21/10 equals b. So I know what my slope is, I know what my y-intercept is, so I'm ready to write my linear equation. So y equals negative 3/10 x minus 21/10. Or if you want to put 2 1/10 instead of 21/10, that would be fine, whatever you choose. Now, I am going to erase this to make some more room. Now let's go ahead and let's find a line that's perpendicular to this line. All right? So, if the slope of my given line is negative 3/10, then my perpendicular slope would be change the sign, positive, and flip the fraction, 10/3. So I know what m is. Now all that I have to do is find b. And of course our formula for finding b is y equals mx plus b. So we'll pull that right over here. And here we go. Here's my ordered pair. So for y I'm going to substitute 0. For m I'm going to substitute 10/3. For x I'm going to substitute -7. And now let's go ahead and get started. 10/3 times -7 is -70/3. And then bring the -70/3 over and make it positive, and we see that b is 70/3. Or if you want to put, let's see, what would that be? 23 1/3. That would be the same thing. I have no problem with that. Either one of these two are the same. So we know what the slope is. We know what the y-intercept is. So my linear equation that is perpendicular to this linear equation is y equals, my slope is 10/3 x plus 70/3, or plus 23 1/3. Okay, two more of these and then we'll be finished. Now this one here, look at the last two. On 61, notice y was already by itself. On 63, y was by itself. On 65, y is not by itself. So I'm going to quickly bring the 3x over and make it a -3x. Now divide each term by 4 and you're going to see your slope is a -3/4 x. -3/4 x. So now we know the given slope, the slope of the given line or the given linear equation is m equals -3/4. So let's go ahead. Let me get a drink here real quick. Let's go ahead and let's find a linear equation of a line that's parallel to this line and passes through this point right here. So here we go. I already know that if my given slope is -3/4, then I'm going to put parallel symbols, then my parallel slope would have to be the same thing, -3/4. And I know the line passes through this point here, so all that I have to do now is find b. So in order to do that, I use my formula here to solve for b. And so where the y is, I'm going to substitute -2. Where my m is, I'm going to substitute -3/4. Where x is, I'm going to substitute 3. And then positive b. So with that in mind, we're going to go ahead and simplify the right side. So I would have -2 equals -9/4. 3/4 times 3, -9/4 plus b. And then bring the 9/4 over and make it positive. So you'd have a -2 plus a 2 1/4, and that should give you 1/4 for your b, 1/4. Okay, so I know what the slope is, I know what the y-intercept is, so I can now write my linear equation y equals -3/4 x plus 1/4. Okay, so we just found the equation of a line that's parallel to this equation up here. All right, let's go ahead and take a look at the next part of this problem and then we'll move on. Okay, let's write a linear equation. I forget what the slope was. What was the slope? -3/4. Okay. We know our given slope, we already found that earlier, is -3/4. And now we're going to write the equation of a line that's perpendicular to this line. So if I know if my given line has this slope, then the perpendicular slope that I'm going to use is, well, it's negative, so I'm going to put a positive. It's 3/4, so I'm going to use 4/3. So I have my slope, and I know the line I'm looking for passes through 3, -2. So now all that I have to do is use my formula that I've been using all along to help me find b. Y equals mx plus b. And where the y is, I will substitute -2. Where the m is, I will substitute 4/3. Where the x is, I will substitute 3. And then bring down your positive b. Now we're trying to solve for b. Let's simplify the right side of the equation. 4/3 times 3/1 is 4 plus b. Now bring the 4 over and make it a -4, and that would give you -6 equals b. So I know what the slope is, I know what the y-intercept is, I'm ready to write the equation. Y equals 4/3 x minus 6. This linear equation right here would graph a line that is perpendicular to the graph of this line up here. All right, let me get a drink. And we have one more of these types of problems, then we'll go ahead and get into the word problems, okay? All right, now this one's this one is very interesting, and I'm pretty sure I noticed this when I gave it to you. This is going to be a challenging problem, okay? This is going to be hard because it's x equals -1. I mean, my goodness. How in the world can we even find the slope? Well, look, students, don't forget, whenever you have just single variable equations, they're so easy to graph. I think in this rare moment, it would probably be helpful if we just quickly got a picture of the line we're talking about, okay? Just trust me, it'd be a big help, okay? So the line they've given to us is x equals -1. Now, if you've studied your notes and done your homework, you should remember that whenever you have a linear equation that has only an x in it and no y, it will be a perfectly vertical line. So I am going to have a vertical line. So I'm going to go ahead now and put a vertical line up here, and I know that because I have just x by itself. And so I know I'm going to have a vertical line, and this vertical line will be at where? X equals -1. So let's pick this up and let's put it right over here, -1. There. There is your vertical line. Now, please listen. Next, let's put this point on the graph. 3, -3. So right here. There. 3, -3. Now, I have a question for you. Now listen to me, they want you to write a linear equation that is, first of all, parallel to this given line. Well, look, guys, if I draw a parallel line, it's obviously going to be vertical, and I know it's got to go through this point right here, correct? So if it's got to go through this point here, what is this point called? 3, -3. It has to go through this point, and it has to be parallel to this line right over here, this black line right over here. So there's a parallel line. Now I have a question for you. What is the name of that line? Well, it's vertical, so I know I'll have just an x in it. And where does it cross the x-axis at? 3. So there. X equals 3 is an equation of a parallel line, or of a line that's parallel to your given line. There it is. Now, next, they want us to find a perpendicular line. Well, it just makes sense to me. Your perpendicular line has to pass through this point here. So here's your perpendicular line. So there we go. This line right here, this green line, is obviously horizontal, thus it's perpendicular to the vertical line. Now I have a question for you. What is the name of this green line? Well, think about it. It's horizontal, so I know it has to be a y equals equation, and it passes through the y-axis at -3, so it must be y equals -3. So this equation right here I'm circling is parallel to the given line, and this equation right here I'm circling right here, y equals -3, that's perpendicular to the given line here. Okay, not very easy, but a good thinking problem, one that'd be very good for you to have to work with. Okay, so there we go. Now let's jump on to 6 word problems and we'll be finished with this assignment. All right, 75 through 85. Number 75, the graph below illustrates the upward trend, in twin births. Now I wonder if I thought I had these pictures saved. Let me pause the video and see if I have that picture here on that's in the book so I can put it on the screen. I'm pretty sure I have that somewhere. Okay, I found that picture. Let me very quickly put that into the video here. There we go. Okay, let's continue on. So we have something to look at here. Model the data with a linear function. Let the independent variable represent the number of years after 1995, and so on. Now, let me show you what they're saying here. If you'll look in your book, please, at the problem, they give you these ordered points right here. Would you please look in your book? 0, comma, 96.7. Now notice this 0 refers to the years past, or in other words, what year. So they're using 0. Here's 1995, and in 1995 there were let's see, 96.7 thousand twin births. But notice they're not using a 5, even though it's 1995. Does everybody see the 1995? Even though it says 1995, they're not using a 5 for X, which is fine. As long as they're consistent, that's fine. They're using a 0 for 1995. So what are you going to use for 1997? 1. What are you going to use for 1999? 2. What are you going to use for 1990 or for 2001? 3. So your ordered pairs would be 0, comma, 96.7, and the next ordered pair would be 1, comma, 104.1, so on and so forth. So if you were to draw a line, do you kind of see how it lines up somewhat in a straight line? So they want you to pick any 2 points that you want to pick and use those 2 points to write a linear equation. So the 2 points I'm going to pick are going to be 0, comma, 96.7. That's this point. Now I'm going to go to the end. I'm going to choose, remember this was 0, this is 1, 2, 3, this is 4. So this ordered pair would be 4, comma, 128.7. So I'm ready. Let's go ahead and write our linear equation. Remember, to write our linear equation, we need our slope and we need our y-intercept. So your slope is y minus y, 96.7 minus 128.7 over x minus x, 0 minus 4. Now I have my calculator here somewhere, or at least I thought I brought it over. Here it is. So very quickly, 96.7 minus 128.7 would give me negative 32 over negative 4, which is a positive 8. So I know my slope is 8. Now all that I have to do is find the y-intercept. So I know the formula to use. Y equals mx plus b. Now it doesn't matter which ordered pair you use for your y and for your x. Just pick one. I'm going to pick this ordered pair because I feel like it. So for y, I'm going to put 96.7. For m, I'm going to substitute 8. For my equal sign there. For x, I'm going to substitute 96.7 and then plus b. Now, 8 times 96.7 gives me 773.6 plus b, and this is 96.7. So bring the 773 over and make it negative, and you will end up with negative 676.9 equals b. So I know what my slope is, I know what my y-intercept is. Now I can write my linear equation. Here it is. My linear equation is y equals, here's your slope, 8x minus 676.9. There it is. So we did part A. We wrote a linear equation that models the information given in the graph. Now part B says to predict the number of twin births in 2007 and 2010. Okay, no problem. Let's take just 1 second to do this. We'll pull this up here. Now don't forget. Now come on. Remember this, 1995 is 0, 1997 is 1, 1999 is 2, 2001 is 3. And so they're going by, on this scale, it looks like they're going by every 2 years counts as 1. So 2003 would be 4. So here we go. 2005 would be 5. 2007 would be 6. 2009 would be 7. And 2011, now watch this, 2011 would be 8. So what would 2010 be? Well, think about it. If 2009 is 7 and 2011 is 8, then 2010 10 would be in the middle, it would be 7.5. So for the year 2007, we're going to use 6, and for the year 2010, we're going to use 7.5. Okay, so there's my numbers I'm going to use. So let's first of all estimate the number of twins in thousands in 2007. I'm going to put 6 in for x. So 8 parentheses 6 minus 676.9. And if we do the math on that correctly, we would get and I'm wondering here quickly, you know how we all make mistakes, I'm wondering if my linear equation is correct. I do apologize for making mistakes, but let's see here. And I did mess up, and you students probably saw that, didn't you? I'm sorry, guys. Hate that when that happens, but that does happen. For my y, I would substitute 96.7, and for my x, I would substitute a 0, not this, so I do apologize. Sorry about that. And that will totally change your b. So a times 0 is 0. So 96.7 does equal b. Okay, so I apologize for that mistake. It does happen. So your linear equation would be y equals 8x. Let me get a drink here real quick. Plus 96.7. And now that we've found our linear equation, we're going to go ahead and do part B, which is to find the number of twins in 2007 and 2010. Now, for 1995 we used 0, here we used 1, here we used 2, here we used 3, here we used 4. So in 2005 we'd use 5, in 2007 we would use 6. Now, in 2009 we would use 7, and in 2010 we would use 7.5. So let's go ahead and substitute a 6 in for my x for the year 2007. And if you do that correctly, you will get, let's see here, 48 plus 96.7. And the estimation for the year 2007 would be 144.7 thousand. Okay, now let's go ahead and substitute 7.5 in for x right here. 7.5. So we have 8 times 7.5 plus 96.7, and you will get out for 2010 the estimation is 156.7 thousand. Okay, a little rough there on the problem. I do apologize for making that mistake earlier, but it happens, and there's no way I would restart a whole video just to fix that one mistake. So that is how you do the problem. And let's continue on now to number 77. Let me get a drink here. And I believe we need a picture for number 77 also. And there it is. Let me pull this over real quick. There we go. Okay, number 77 reads as follows. Model the data given in the table below with a linear function, and then estimate the average monthly cell phone bill in 2007 and 2009. Answers may vary depending on which data points that you use. Okay, so we see here in the table, they're going to let the year 2000 be 0, and there's your phone cost. The year 2001 is 1, it costs this. So in other words, you have a bunch of ordered pairs, students. This will be a pretty easy problem compared to the last one. You have 0, 45.27, 1, 47.37, 2, 48.40, etc. Now, it really doesn't matter which two ordered pairs you pick. I'm just going to pick the first one and the last one because that's just almost always how I do that. You don't have to do it that way. That's how I do it. So my first ordered pair is 0, 45.27. The other ordered pair I'm going to use is 4, 50.64. Now, let's go ahead and write the linear equation. Remember, we need two things to write a linear equation or a linear model. M, and B. Well, let's first of all find the slope. We have 45.27 y minus y, 50.64 over x minus x, 0 minus 4. So let me grab my calculator real quick. 45.27 minus 50.64 would give you negative 5.37 over negative 4. So if we type that into our calculators, I'm going to go ahead and round the slope to 1.34. Now, if you rounded somewhere else, that's fine. I'm just estimating 1.34. A negative divided by a negative is a positive. Now, let's use our formula to find b. Y equals mx plus b. It does not matter which point you use. I always like to use the point that has a 0 if there's one like that. And so for y, I'm going to substitute 45.27. For my slope, I'm going to substitute 1.34. And for my x, this time I'll be sure and get it right, I'm going to substitute 0. And there we go. 1.34 times 0 is 0. 0 plus b is b. So 45.27 equals b. So now I know what b, or my y-intercept, is. So let's go ahead and write our linear model, and then we're almost finished. My linear model would be 1.34x plus 45.27. Now they want us to predict the cost of cell phones in 2007 and 2009. So here's 2007, here's 2009. Let me get a drink here real quick. Now, notice in 2000 we used a 0 for x, in 2001 a 1, in 2002 a 2. So in 2007 we're going to use a 7 for x, and in 2009 we're going to use 9. So I come over here, and where the x is, I'm going to substitute a 7. So now it's just a calculator problem. I simply take 1.34 times 7 plus 45.27, and I will get the estimated amount in 2007 to be $54.65. Okay? And now in 2009, so now I'm going to substitute a 9 right here for x, and now it just becomes a calculator problem. 1.34 times 9 plus 45.27, and the average estimated cell phone cost in 2009 is $57.33. Okay, so there we go. Moving on to number 79. Let me get a drink here, and we'll continue on. And it looks like for 79 we're going to need another picture, so let's go ahead and cut this real quick here. Alright, there we go. Okay, let's read number 79. Model the data given in the table below with a linear function, and then estimate the average monthly Social Security benefits for retired workers in 2005, and then also estimate the average in 2010-2020. Answers may vary depending on what data points you used. Well, once again, thankfully, they're letting us use 0 for 70, 10 for 80, 20 for 1990, so on. So that's good. I'm going to use these two ordered pairs here. I'm going to use 0 and 123.82, and then 33 and 92.10. So those are my two ordered pairs, 0, 123.82, and my other ordered pair would be 33, 922.10. Now let's go ahead and write our linear equation. First of all, I have to find my slope, so I'm going to take y minus y over x minus x. If I take 123.82 minus 922.10, I will get in my numerator negative 798.28. And then of course x minus x is 0 minus 33. That's negative 33. Now if you divide those two numbers, and don't forget a negative divided by a negative is a positive, and I'm going to round it to 24.2. So that would be your slope. Now let's find our y-intercept, okay? And I'm going to go ahead and show you a shortcut I think would be very helpful to you. Did you notice in the last problem we had an ordered pair that was 0, 45.27? Do you see that? And what did b end up being? 45.27. In this last problem, we had an ordered pair that was 0, 96.7 right here. right here, 0, 96.7. And what did my y-intercept end up being? 96.7. That is a shortcut that always works. So I don't mind you using that shortcut as long as you first learned how to use y equals mx plus b, because sometimes you're not given an ordered pair that has a 0 right here for x. And when you're not given an ordered pair like this one, then you're going to have to use y equals mx plus b. Okay? But anyways, because I have an ordered pair that is 0 comma something, I do know that my b, my y-intercept, will be 123.82. So now I can write my linear equation. Y equals 24.2 plus 123.82. Now this is a model that is a model of the average monthly Social Security benefits for retired workers. Now they ask us then to predict the amounts, average monthly amounts for the years 2005, 2010, and 2020. Well, guys, if you'll look, they're going by ones. I mean, 70 is 0, add 10 more, 80 is 10. So 1971 would be 1, 1972 would be 2, 1979 would be 9, 1980 is 10, 1981 is 11, 1982 is 12. So if 2003 is 33, then 2005 would be represented by 35. 2010, add 5 more, would be represented by the number 40. And then going from 2010 to 2020, the number 50 would represent 2020. So now it's just math problems. I did forget my X right here, but now it's just math problems. I mean, in order to predict the monthly amount of Social Security in 2005, you simply put where the X is, you substitute 35. So now it's just a calculator problem. So if you put 35 in for X, 24.2 times 35 plus 123.82 would give you this monthly amount, $970.82. Okay? Now let's try 2010. So now where the X is, we're going to cross off the X and we're going to substitute a 40. Okay? So now we have 24.2 times 40 plus 123.82, and that's going to give you $1,091.82. Okay? And then we're going to put 50 in to get out the average monthly amount of Social Security. So where the X is, I'm going to cross that off. We'll put a 50 right there. So 24.2 times 50 plus 123.82 is going to give you $1,333.82 per month in 2020. Okay, so there we go. Same type of problems, just writing linear models and then making predictions. Okay, long homework assignment, but we're almost done. 3 more problems and we're finished. Number 81, and it looks like 81 does need a picture. So see if I can find that here quickly. There it is. Let's cut that out. And let's read the problem, number 81. A person who is exercising should not exceed their maximum heart rate, which is determined on the basis of the person's age, their gender, their resting heart rate, etc. The following table relates resting heart rate and the maximum heart rate for a 20-year-old man. Okay, so if your resting heartbeat is 50, then your maximum heart rate should be 166. If it's 60, then your maximum heart rate should be 168. If it's 70, then it should be 170, etc. So we have some ordered pairs here, it looks like to me. Now, it says use a graphing calculator to model the data. Now, we did not yet learn how to do that. We're going to try to learn that later, but we can do it the old-fashioned way, in which we write the linear model just using 2 ordered pairs. So I have 50, 166 is one ordered pair, and the other ordered pair is 60, 168. Now I'm going to write the linear equation. Okay, so for my slope, I need to find my slope and my y-intercept. Okay, so y minus y, that's 166 minus 168, and of course that's going to give me a negative 2. And then my x minus x, 50 minus 60 is negative 10. So a negative, not sure why I wrote it there where b is, but I would have a negative 2 over a negative 10. So a negative over a negative is positive, and 2 divided by 10 is simply 0.2. So a positive 0.2 is your slope. Now notice none of my ordered pairs have a 0 here or here, so I am going to have to use y equals mx plus b to find my b. I'm going to use this ordered pair because I just chose to. Where the y is, I'll put 166. Where the m is, I will put 0.2. Where the x is, I will put 50, and then plus b. If you multiply 0.2 times 50, you will get 10. And so we have 166 equals 10 plus b. Bring the 10 over and make it negative, and you're left with 156 equals b. So now I know my y-intercept or my b is 156. So I am finally ready to now write my linear model, and my linear model would be y equals 0.2x plus 156. So what does this model do for me? Well, I can plug in an x, and don't miss the point here that x is the the resting heart rate. So you can tell me what a resting heart rate is. I will plug it in right here, and I will get out what your maximum heart rate should be so that you don't hurt yourself while you're exercising. Now, look at question B. They want us to estimate the maximum heart rate if the resting heart is 40, 65, 76, and 84. That sounds like a lot of work, but it's really, really simple. You're simply going to substitute a 40 in for x, and then a 65 in, then 76 in, and then 84 in. We can do it very quickly. If you substitute 40 into that equation, you will get out that your maximum heart rate is 164. And if you were to substitute 65 in, like they've asked us to do, if your resting heart rate is 65, then your maximum heart rate when you exercise will be 169. And if you substitute 76 in, if your resting heart rate is 76, then your maximum heart rate would be 171.2. And then if your resting heart rate is 84 and you substitute that into the equation, your maximum heart rate when exercising would be 172.8. So really not that hard. Now I think in the book they wanted you to use H and M instead of X and Y, and that's no big deal. You would have had 0.2 H right here, and over here you would have had an M instead of a Y. And that's totally fine to do. We really should try to do that when they want us to, but you still have the same linear relationship. Okay, 2 problems left. Let's take a look at number 83. And I think number 83 does require a picture. Let's get that real quick. Alright, number 83 reads as follows. From 1992 to 2002, sales of Easter candy remained relatively constant as shown in the following figure. Okay, we're not going to use a graphing calculator. We're going to do it the long way. They want us to write a linear model. Now, it's up to you what you let represent each of these numbers right here. I'll tell you something that's kind of interesting to do. If you wanted to let 0 represent 2000, you could do that. And what would 1999 represent, Mr. Hart? -1. You can do that. There's nothing wrong with that. So we could say the year 2000 is represented by the number 0. It makes it easier. So the 2001 is represented by 1. 2002 is represented by 2. You can do that as long as you call 1999 -1. That's totally acceptable. Okay? So I'm going to use these 2 ordered pairs to write my linear equation. Remember how it's always easier to find B when you have an ordered pair that starts off with 0. So I'm going to use this ordered pair here, 0, 1.9, and then come down here and I'm going to use 2, 1.8. Now you could have used any 2 points that you want. I just chose those randomly. Now let's go ahead and write our linear equation. Okay, so here we go. We know that we need our M, and we know that we need our y-intercept. So y minus y would be 1.9 minus 1.8, which would be 0.1. And then x minus x is 0 minus 2, and that's going to be a negative 2. If you type this into your calculator and divide, you will get a negative 0.05. And we know what the y-intercept is because we wisely chose an ordered pair that had a 0 in the first place. So we know my b is going to be 1.9. So now we can write our linear equation very quickly. It's y equals negative 0.05x plus 1.9. So there we did it. Now it says estimate the sales of candy in 2005 and 2010. Well, students, that's going to be really easy. 2005 is represented by the number 5, so I'm going to substitute a 5 right here for x. Okay, and so I have negative 0.5 or negative 0.05 times 5 plus 1.9, and we're going to get 1.65, that's billion dollars, $1.65 billion in Easter sales that year. Still relatively close to all of these being pretty much the same. And then they want us to predict the amount in 2010. And so in 2010, we would go ahead and substitute a 10 right here for x. And so we would now have negative 0.05 times 10 plus 1.9. And we would get 1.4. So the estimated amount in 2010 is going to be $1.4 billion in sales. Okay, so pretty good job. We have one more problem left and we're just about finished here. All right, number 85. And on number 85, Matthew and Caleb, you guys get off a little easy. I just realized on number 85, I was telling you to go back to number 75. Go ahead and follow along if you would, please. It says use a graphing calculator to fit a regression line to the data in exercise 7.5. And so we are going to learn how to do that. We first wanted to learn how to do it manually using formulas, and then secondly, we'll learn how to use technology. But we really can't go back and do that to number 75 because we've not yet learned how to do that. So you get one problem off on your homework assignment, so good for you guys. And that's it for this homework help video. If you have any questions, excuse me, don't hesitate to call or email if you have any questions at all.